Assalamu alaikum, dear students. This is Shamshad Ali, Department of Technology, Surrey University. Today we are going to learn about the condition of lateral earth pressure. There are three types of condition, and in today's lecture we will be familiar with these three condition of the lateral earth pressure. This is our week 8 or lecture 8, 5th semester, the BSc Civil Engineering Technology. You can access this lecture at portal.su.edu.pk. So let's proceed to our today's lecture. The first condition of the lateral earth pressure is the at rest condition. Simply, the at rest condition means when the retaining wall does not move against the backfill and towards the backfill. This is simply at rest condition. Let us assume a certain retaining wall is both rigid and unyielding. For example, if we have a wall which is rigid and as well as the unyielding. In this context, a rigid wall is one that does not experience any significant flexure moment. There will be no flexure moment, no tension and no compression, and no flexure moment. The opposite will be a flexible wall, one that has no resistance to flexure. The term unyielding means the wall does not translate or rotate as compared to a yielding wall that can do either or both. So let us also assume this wall is built so that no lateral strains occur in the ground. There will be no lateral strain in the backfill material. Therefore, the lateral stresses in the ground are the same as they were in its natural undisturbed state. The most accurate way to evaluate K0, basically K0 will represent the coefficient of lateral earth pressure at rest condition. So K0 will be to measure the sigma prime x in situ using a deltometer, pressure meter, spared cells, or some other test. Compute the sigma prime to z, mean the vertical stresses. This is the horizontal stresses, the minor stresses, and these are the major stresses, the vertical stresses, using in situ measurement techniques. Then compute the K0 using equation 1. We have equation 1. This is basically the equation 1. If we want to calculate the coefficient of lateral earth pressure at rest condition, then you have to learn about this equation. This equation is basically the K0 is equal to the 1 minus sine the alpha base, sorry, the K0 is equal to 1 minus sine theta prime, the OCR sine into theta. K0 here represents the coefficient of lateral earth pressure at rest condition, K0. And this is basically the effective friction angle of the soil, theta. OCR is the ore consolidation ratio of the soil, as we have learned in soil mechanics. Ore consolidation ratio, normally consolidation ratio, and the under consolidation ratio. Okay. However, these in situ tests are not often used in engineering practices. So we usually must rely on empirical correlation with other soil properties. If you want to use the spared cells, so here we have a picture of the spared cell. This is basically the spared cell. If you want to measure the lateral stresses in a soil, you have to insert it, but it is most costly equipment basically. And this is basically the pressure meter test PMT ASTM 4719. You want to insert, if you want to measure the lateral stresses, you have to insert this spared cell, and then it will be connected with a data logger to which you can calculate the lateral stresses. This is basically the spared cells. Okay. Several such correlations have been developed, including the following by Main and Kolhavi in 1982, which is based on the laboratory test on 170 samples that range from clay to gravel. Mean they conducted a laboratory test on the 170 soil samples. They include the clay to the gravelly soil samples. This formula is applicable only when the ground surface is level. The correlation will be applicable when the surface is level above the backfill. For gravity walls that are backfilled with sandy soil and have footings founded on bedrock, Duncan et al. In 1990 recommend using K0 is equal to 0.45 if the backfill is compacted, or K0 is equal to 0.55 if the backfill is not compacted. As we have learned in the previous lecture, that the K0 value will be depend upon on the type of the soil, and as well as in the consolidation ratio. If no groundwater table is present, the lateral earth pressure sigma prime x acting on a rigid and unyielding wall is in theory is equal to the horizontal stress in the soil. Sigma prime x is equal to sigma prime z, mean the vertical stress, into the K0. As we have learned that the K0 is basically the ratio of the vertical stresses to the horizontal stresses. At rest condition is basically theoretical. Basically, the wall is not at the rest condition. Mainly, it is probably it will be in active condition and will be in passive condition as well. But at rest condition is basically theoretical condition. In a homogeneous soil, K0 is a constant and sigma prime z varies linearly with depth. As you can see in this picture, that the sigma prime z varies linearly basically. It can vary different in the throughout the depth. Therefore, in theory, sigma x also varies linearly with depth, forming a triangular pressure distribution is shown in this figure. This is basically a pressure distribution. This is the unit length. Basically, the B represents the unit length per unit length. This is basically the gamma into K0 into H at rest lateral earth pressure. Thus, if in rest conditions are present, the horizontal forces acting on a unit length of a vertical wall is the area of the triangle. If you want to calculate the horizontal forces acting on a unit length, you have to find the area of the triangle basically. And here we have, this is basically P0 divided by B is equal to gamma into H square into K0 divided by 2. As we have as we know that the triangle, when you want to find out the area of the triangle, so the formula is basically the area of triangle is equal to half of the breadth of the height. Normal forces acting between soil and wall per unit length of the wall, P0 divided by B is equal to this formula. This formula is basically derived from the triangle formula, area of the triangle formula. B is equal to unit length of the wall, usually 1 feet or 1 meter. Gamma is the unit weight of the soil. As you know, the unit weight of the soil, height of the wall, There you can calculate in the in situ the height of the wall, and Kn is the coefficient of the lateral earth pressure at rest condition. So there you can calculate the horizontal stresses acting on the wall at rest condition basically. Now the second one is the active condition. The at rest condition is present only if the wall does not move. Although this may seem to be a criterion that all walls should meet, even very small movement alter the lateral earth pressure. If there is movement, so the rest condition it changes from the to the active condition or to the passive condition. Suppose Mohr circle A in the figure, in this figure basically. This is basically the figure 223.3 in your book, in your the handouts, the detailed handouts in your portal. This is basically the at rest condition. This is the Mohr circle, Coulomb-Mohr circle, and this is the Coulomb-Mohr failure plane basically. When this circle moves, come to this at rest condition, suppose Mohr 23 represents the state of the stress at a point in the soil behind the wall in figure, and suppose this soil is in the at rest condition. This is basically in the at rest condition basically. The figure A here. Wait, I will. This is basically this here. This is basically the at rest condition. Okay, so the inclined line represent the Mohr Coulomb failure envelope, as I show you. Because the Mohr circle does not touch the failure envelope, the shear stress tau is less than the shear strength basically of the earth. Here we have, this is basically the failure plane, Mohr failure envelope basically. So this circle does not touch the failure plane. So this is at rest condition. Still stays. It is the at rest condition basically. So now, okay. Now permit the wall to move outward a short distance. This movement may be either translational or rotational about the bottom of the wall. It leaves part of the horizontal stresses, causing the Mohr circle to expand to the left basically. Now come to this if this wall basically here, this is the wall, or here, or the wall move to the left side, then the stress, the condition of the stresses become changed. Now the circle touches the failure plane criterion, and now this condition is active condition. Okay, continue this process until the circle reaches the failure envelope and the soil fails in shear, as the circle B represents. This is basically the circle B. Now it touches the failure plane. Okay, this shear failure will occur along the plane shown in the figure as I showed you, which are inclined at an angle of the 45 plus pi divided by 2 degrees from the horizontal. A soil that has completed this process is said to be in the active condition. The value of K and C mean the cohesionless soil, and the active condition is known as the Ka basically. Now the coefficient of active earth pressure will be represented by the K into small a. Okay. Once the soil attain the active condition, okay, the horizontal stresses in the soil and thus the pressure acting on the wall will have to reach its lower bound, as shown in the figure. This is basically. Now this movement away from backfill. So Ka. Here this condition is the active condition, and here this condition is the basically the passive condition. This is the coefficient of the lateral earth pressure. If it reaches here, then this will be the Kp, coefficient of lateral earth pressure in passive condition, and here it is the coefficient of lateral earth pressure at the active condition. Okay. The moment of the wall required to reach the active condition depends on the soil type and the wall height, basically. For example, in loose sand, the active condition is achieved if the wall moves outward from the backfill a distance of only 0.004 of the height, about 12 mm for a 3 meter tall wall. Although basement wall being braced at the top cannot move even that distance. A cantilever wall, one which is the top and top is not connected to a building or other structure, could very easily move 12 mm outward, and thus a movement would usually be acceptable. Thus, a basement wall may need to be designed to resist the at-rest pressure. Whereas the design of free standing cantilever wall could use the active pressure. Since the active pressure is similar, the design of the freestanding wall will be more economical. This is basically the changes in the stress condition in a soil as it transition from the stress condition to the active condition. This is basically the active condition. Basically, active condition is basically when the soil exert pressure on the wall and it move in this direction, basically. My drawing is a little bit rough. So this is basically the active condition, movement in this direction. The shear failure plane are here, and the angle of the here it can make an angle of 45 plus pi divided by 2. This is basically active condition. Now we come to the third one, which is the passive condition. The passive condition is the opposite of the active condition. In this case, the wall moves into the backfill, as shown in the figure. This is basically passive condition. Is here you can see the passive condition. This is the active condition, and basically this is the passive condition, opposite of the active condition. Okay. Wall moves into the backfill, and the more circle changes as shown in the figure. Here you can see this is basically the at-rest condition, and this is basically the passive condition. Here this is the active condition, this is the at-rest condition, this is the passive condition. Okay. Notice how the vertical stress remains constant. Vertical stresses will be constant where the horizontal stresses changes in response to the induced horizontal strain. In homogeneous soil, the shear failure planes in the passive cases are inclined at an angle of 45 minus pi divided by 2. In the active condition, the angle will be 45 plus pi divided by 2. And here it is the 45 minus pi divided by 2 degrees from the horizontal. The value of K in a cohesionless soil in the passive condition is known as the K, the passive coefficient of lateral earth pressure. This is the upper bound of the K, and produce the upper bound of pressure that can act on the wall, basically. Engineers often use the passive pressure that develop along the toe of the retaining wall footing to help resist sliding, as shown in the figure. In this case, the wall is the side of the footing. Here you can see, to resist the sliding, you can design the wall to the passive pressure, to the passive condition, basically. Now we are going to watch a video to demonstrate the active condition and the passive condition as well. density of water. Uh, this is basically the generation of the stresses. This is basically the stresses. We are going to demonstrate the bond. Basically, the rotating. This is the rotating bond. This is the glass marble which is used to induce the forces. The L shape is outside. This is the overturning basically. This is basically the active condition. Now this is an active condition. The wall against the backplate. Now to increase the friction they use a rubber plate. Rubber plate. Now you can see this is basically the active condition. The condition is active basically. Now as you can see there is no now. Now it reaches to the active condition. Now this is the active condition. The wall against from the back. Now filling. So the purpose of this video was to demonstrate the active condition basically. If this wall moves in this condition, in this direction, then it will be the passive condition. And if it does not move, then this will be the basically the passive condition. So this is it for today's class. Hope you will learn something. In next class, inshallah, we will learn about the classical lateral pressure theories, which is Coulomb's theory and the Rankine theory as well. So thank you so much. If you have any question,